training on measurement of building works on Planswift. So today we'll be strictly on basic understanding of Planswift and how to take off for building works, particularly structural works. So I'm trying to open the Planswift, so it's still loading. I hope you can see my screen. Can you all see my screen? Hello?
Yes, I can see your screen, sir.
Okay, so I'm trying to upload a new drawing. It's a building drawing. So first of all, this Planswift interface. I hope you are all familiar with Planswift. Hello? Are we all familiar with Planswift? So I will just start from basic, step by step.
No, sir. I'm just getting to know it, sir, for the very first time.
Okay. So Planswift is one of quantity surveying softwares, majorly for taking off, prepare labor and material schedules. So the essence of using Planswift is just to make our work easier as a quantity surveyor and to prevent errors and some other mistakes that could be made by using manual quantity takeoff. So first of all, I would like to explain all these icons to you. The Planswift being the first icon on this menu. So the second icon is home. So the home is the area whereby our drawing will be displayed. So on home, we have new. Maybe we want to upload new drawing. We just click on this new to upload our new drawing from external source. So open, maybe we have already uploaded drawing and want to open the drawing, want to continue our job. You can click on this open. You can see all the work I've been doing on Planswift. So maybe I need to work on any of these projects. Maybe I want to add or omit something there. Maybe there's variation on a particular area. I'll just open the drawing and add or deduct from that particular area that's being affected. So that's the function for open, to open the already uploaded drawing on Planswift. So print, you can print all our taken off on Planswift, provided that we are connected with printer. We just click on this print. We can email our job to our client or other parties involved in a particular project. So we have page 2. Maybe we want to rotate our drawing. Maybe it's not properly placed. You can click on this rotate to rotate our drawing. You can see my drawing is rotating maybe to the left, right, or at 180-degree angle. So tools, we are not seeing all this one. We are not concerned about all these tools. Fill, we are not concerned about this fill too. So estimating, the estimating is the place whereby all our quantities, all what we have taken off for, will be displayed for exportation to Excel. Maybe I want to export all these quantities I've taken off for. So I'll just click on this estimating and click export to Excel. Once I click on this export to Excel, it will be exported to Excel. For maybe I want to incorporate it in my bill of quantities that have already been prepared in Excel. Hope you are all hearing me. Am I communicating, please? I want to know.
Yes, you are. I'm with you, sir.
You are getting me. Am I speaking? Is my voice audible to you? Hello?
Loud and clear. Loud and clear.
Okay. And you are getting me well?
Yes, I am.
Okay, so without wasting much of our time, so let me upload new drawing we are going to work on today. So if I want to upload new drawing, I'll click on this home. As I said earlier, you click on this new icon. Having clicked on this new icon, it brings this interface. So job code. So what code do I want to name my work. Maybe I want to name it QC-03. You can choose your code. All projects you do have code. Maybe your project code is QC-03 or 02, any code you like. So I will input the code QC-03 and the job description. What is the description of the job we want to do on this project by using this Planswift? So our major focus for today's lecture is to take up for structural elements by using the normal tools in Planswift, and again introduce us to plugins. The plugins, how to create plugins to make our work more easier than using the Planswift tools. So I just click measurement of structural elements. So measurement of structural element. So having done that, so we see measurement type. So if our measurement type is not in metric, so we have to change to metric because all our measurements in Nigeria are into meters. So after doing that, we click on next. So having clicked on next, it brings all these files. So I will now locate where I save the drawings. So I will look at it on this one. So the project I want to work on is on. So it has uploaded. So we have structural drawings and architectural drawings inside this folder. So this is the architectural drawing. This is the architectural drawing. So this is the structural drawing for these projects. This is structural drawing. So first of all, we start with architectural drawing by taking off our site clearance. So I'll click on architectural drawing here. So this is our site layout. This is the area of our site. So we are going to do two things today. First of all, we'll firstly use Planswift tools, all these tools. So the first tool here is area. The next tool is linear. Linear just to take off for anything linear meter. Same as this segment. Count to know the total number of something, maybe doors, windows, or anything enumerated. And auto count. Auto count also normally used to count maybe automatic counting. So first of all, we have to scale our drawing. The essence of scaling our drawing is just to make sure that we are not under measuring or over measuring. So if the drawing is not scaled, so we have to scale it by clicking on this dimension. So if you want to scale our drawing, first of all, click on this dimension or click on this scale on this ruler, whichever one. So I'll click on this, so it will bring this scale. After bringing this scale, so I will look at any of these figures on this plan. This one is 32.79 meters. This one is also 37.89 meters. This one is 3.240 meters. So I will pick any of these dimension in order to form my basis for measurements. So let me pick any of these dimension on this plan. So I'll pick this 3.92, this 3.92, 3.92, and click OK. So this is my 3.92. So my dimension for 3.92 is from here to here. So I will scale it to describe what I want to take for. So having brought this, so I will write site clearance. So having done that, I can change the color in which I want it to bring out, maybe black, red, any color, any color of your choice. So I choose blue. After choosing that, I will click OK. So our site area is all these point, cover all these points. So I will start from this point, taking like this. So at every point, I'll be clicking, I'll be left clicking at every point. I'll be left clicking. So after having reached this point, I will click, come down like this, click, go like this, click. So after left clicking here, I will right click again because this is the last point. After left clicking, I will right click here because this is the last point. So I will right click here and I click stop. So this is the total area. So let me show you the total area. You right click on this sheet and click show legend to see the legend of this area. So this is the total area of our site clearance. It's 811.0 square meter. This is the total area of our site clearance. Hope you are following.
Yeah.
Are we getting it? Or I should come again?
Yes, I'm getting it, please.
Okay. So
I'm getting it.
okay. Having done our site clearance, after site clearance is site preparation. So our value for site clearance can also be used for site preparation. So you don't need to take off for site preparation again. So after site preparation, we do trench excavation. We cannot do trench excavation by using structural drawings, except we are not giving details, but we have structural drawings that we can get our trench excavation from. So having done that on structural drawing, having known our site clearance, so we open our structural drawing here. We open our structural drawing. So this is the foundation plan of our structural drawing, and this foundation is Raft foundation. It's Raft foundation, but unfortunately, they didn't give us the depth of our trench and the width of our trench. We were told verbally to use certain values for our depth and width of our trench. So this is the foundation plan. This is the beam details. First of all, I will pick linear tools. So to bring this, it says this tool requires you to scale the page first. Would you like to set the scale now? So whatever I want to do on any page, it will bring this message for me to scale. So I will click yes. As I did for site clearance, I will choose any of this figure on this plan to scale my drawing, any of these figures, these values, these dimensions to scale this page. So let me pick 5.74. Mind you, all your scale you'll be putting here should be in meters. So I will choose, let me pick this value, 5.74. So 5.74. After having inserted that, I'll click OK. And I'll click this point, this first point from here to here. So that's my 5.74. So let me cross check whether this value is correct. I will click this dimension. So let me check this one. So since it's correct, 5.21, 5.20, still okay. Let me cross check. So let me check this. So it's correct. So having done that, I will come up the digital record. I will click this digital record to drop this tool. So I'll click on this to drop the tool. So having scaled our drawing, I will choose this linear tool and put trench excavation. I choose linear tool, and our trench excavation is measured in cubic meter. So how do I want to convert it to meter cube? So if you want to convert this tool to cubic meter, you click on this advanced. So it will bring all these properties. So under estimating, we have quantity, we have cost each. Maybe you want to prepare material schedule. That's where this cost each will be effective. So we are only concerned about this quantity under this estimating. Are we all following? Hello?
Yes, I'm with you.
Yeah, I'm with you.
All right. So after under this estimating, under the quantity, we see takeoff. So after this takeoff, we click on this column and we multiply this takeoff by the width of our trench and the depth of our trench to convert it to meter cube. Mind you, don't delete this takeoff. We just click after this takeoff. So we multiply it by depth of our trench. First of all, the width. I said the width of our trench is 0.68. So 0.68, that's the width, by the depth is 1 meter. 1 meter. So having done that, we come here after this column, we change the unit to cubic meter. We change the unit to cubic meter. So having done that, we click OK. Hope we are getting it.
Yeah.
So we click on this OK. So we now begin to measure for our trench by taking it meter in cubic meter. So after our trench excavation, the next item to take over is level and compact. You have to level out the trenches to receive blinding. So instead of us to start all over again, since we have already known the total length of our trenches and all the length of our trenches is where we are going to put our blinding. So let me check to know the thickness of our blinding. Sorry, level and compact, I mean, before blinding. So having known the trenches, so I want to use these quantities for my level and compact. So I will right click on this trench excavation, the one I've already calculated for. I will right click on this. I will click copy, right click on it again and click paste. So it will bring this message. So it say, would you like to paste the selected sections as new sections in the same item or create a new item? So the first option says paste sections into same item. This second option says paste sections into new item. So I want to create a new item. So I will choose the second option. So I will click OK. So it's trying to copy. So it has copied the trench excavation. So I will double click on this copied trench excavation. So after double clicking on it, I will change the name to level and compact. So, I have to change the properties of this trench excavation to suit this level and compact, because our level and compact is measured in square meter. So I will click on this advanced. And I will remove my depth from this quantity, because depth is not required while measuring level and compact. And I will change this unit of my measurement to square meter, and click OK. So my value for level and compact still 153 per square meter. The reason being that the depth is 1 and 1 is useless. That's why the quantity remains like this. So 153.0 square meter. Are we following?
Yeah.
Okay. So
Sorry, I did not get that, please.
You did not get that? Okay, let me come again. Let me delete the level and compact and do it again. I'm trying to delete it. So what I did was that, since we know that all our trenches is going to be level to receive blinding, it's going to be level compacted to receive blinding, and we've already known all the meters length we are going to level and compact. So instead of us to start taking off for that again, so I will just click on this trench excavation that has already been calculated for, and I will right click on it. I will click copy, right click on it again, click paste. So it will bring this this question that we like to paste the selected section as new section in the same item or create a new item. So the first option says paste section into the same item. No, not the same item. I want to create new item from trench excavation. So I'm not going to follow that instruction, the first option. So the second option says paste sections into a new item. So I want to create new item from trench excavation. So the new item I want to create from this trench excavation is level and compact. So I'll click on this second option. Having clicked on it, I will click OK. So it's copying. So it has copied this trench excavation. So since what I need from this trench excavation is level and compact, so I will just double click on the copied one. The copied one. So I've double click on it. So I will change the name to level and compact. Mind you, the trench excavation still remains. I just copy level and compact. So having done that, you know that our trench excavation is measured in cubic meter, the length, the width, and the height. But our level and compact is measured in square meter. So I have to change the properties of this by clicking on this advance and remove this trench 1 meter from it so that our measurement will be in square meter. So, and I will change this unit of measurement to square meter. So having done that, I will click OK. So these are level and compact. Hope we are clear now. Hello?
Yes, very clear.
Okay, so after the level and compact, the next item is blinding. Blinding after leveling our trenches. So the next item is blinding. So let me check the thickness of our blinding. The thickness of our blinding. Actually, this drawing is not to details as we want. So I don't think the blinding is given actually, because it should be written under the beam. So since it's not given, and we know that there must be blinding in doing raft foundation, there must be blinding because there's going to be reinforcement for ground beam. So they must blind. It's a must for them to blind. So we are going to assume 50 mm thick blinding. We are going to assume 50 mm thick blinding. So again, for this blinding again, we all know that all the trenches we've excavated is going to be blinded. So the total length we got for trench excavation is still going to be used for our blinding. By doing what I did for level and compact, I will repeat that process for this blinding again, because the total linear meter is still the same. The total linear meter we use for trench excavation is total linear meter we are going to use for level and compact, is what we are going to use for blinding, is what we are going to use for our beam, ground beam. So first of all, so I will click on any of these gotten values. Is either I copy from trench excavation or I copy from level and compact to know my blinding, to know quantities for my blinding. So I will click either of these quantity. Is either I click on this trench excavation or I click on this level and compact. So let me copy from this level and compact to know the quantities of my blinding. So I will right click on this level and compact, click copy. I will right click on it again, click paste. So I will choose second option and click OK. So it's trying to copy. So it has copied. I will double click on that copied quantities. So I will change it to 50 mm thick, 50 mm thick blinding. So don't forget to change the properties by clicking advance. You know that blinding is measured in cubic meter. Actually, some people used to measure in square meter by stating the thickness. But yeah, I want to measure it in cubic meter. So I will multiply this the already gotten quantity by 0.05, and I will change the unit to cubic meter, and I click OK. So this is my quantity for blinding, 7.7 cubic meter. 7.7 cubic meter. Are we following?
Yeah.
Hello?
Yeah.
Okay. So having gotten that, the next item is what? After blinding. I want you all to answer. The next
Hello.
item.
Can I say something?
Yeah.
Yeah. I thought the Raft
We are with
foundation,
you.
we are going to
I thought
establish.
someone wanted to ask a question before the breakdown.
Okay, maybe it is Ernest also.
Okay. So I asked a question that after our blinding, what's the next item to take off for? Hello?
You. Very good.
Okay, I'm just trying to confirm whether you're all back.
Yes, we're with you.
Okay, so the next item is ground beam. So, and the size of our ground beam, you can see, is 230 by 1.8, 0.23 by 1.8. That is, the width of our ground beam is 0.23, and the height of our ground beam is 1.8, all true. You can all see here. So, ground beam 130, 230 by 1,800. So, once again, instead of us to start trying to know the total length of our ground beam, since we have already calculated for our trenches, so what we'll do is just to copy the already calculated trenches. Maybe we can copy from trench excavation, level and compact, or from blinding. So whichever one we want to copy from to get our to get total quantities for our ground beam. So let me copy blinding. Copy, paste, and click OK. So it has copied. So I will double click on this copied blinding to rename it to ground beam. So ground beam 230 by 230 by 1,800 mm. So having done that, we are going to change the properties by clicking advance. And we know that the size of our ground beam is 0.23 by 1.8. So the width of our ground beam is 0.23 by 1.80. So the unit remains the same, cubic meter. So we click OK. So we've gotten our quantities for concrete ground beam, which is 93.2 cubic meter. Hope you are getting it. Are we getting it? Hello?
Yes.
Okay. So after calculating for our ground beam, so the next thing to calculate for is to backfill. So from backfill, you can get our disposal. So you know that backfilling, we know that the width of our trench is 680, which is 0.68. And the space occupied by ground beam is 230, which is the width. So if we deduct 230 from 680, so we are left with 450. That is, we are going to backfill 230 external face, and internal face we are going to backfill 230 width. Are we getting it? We all know how to take off for backfilling now. So
Yes.
you know that the space occupied by our ground beam, the width is 230, and the width of our trench is 680. Definitely, we are going to backfill the remaining space left behind that's not occupied by anything. So we are going to backfill 230 outward, 230 inward. So we still need the total linear meter we've already calculated for to know the cubic meter of our trench. So I can copy this trench excavation. I can copy this trench excavation, copy, paste, choose second option and click OK. So it has copied. I will double click on it to change the name to backfilling. Backfilling. So don't forget to change the properties because I copied this from trench excavation, and the values for our trench excavation is different from backfilling. So I have to change the values by clicking Advanced. So we all know that the width to backfill is 0.45. I got 0.45 by deducting 230 from 230 being the width of our ground beam from the width of our trench, 680. So we are left with 450, which is 0.45. And the height of our trench remains the same, 1.00. So I'll click OK. So we click OK. So this value for our backfilling, 101.3 cubic meter. So to know our disposal, we all know that trench excavation is equal to backfilling plus disposal. So meaning that trench excavation minus backfilling. So the value we get is going to be for our disposal. Hope you all get it. Do you get it? Hello?
Yes, we are with you.
So we know
very well, sir.
We all know initially from our school that trench excavation is equal to backfilling plus disposal. So now we never get value for our disposal. We've gotten value for trench excavation. We've gotten value for backfilling. So it's just to deduct backfilling from trench excavation to know our value. Or you can know your disposal by knowing the total quantities of our blinding, total quantities of ground beam to the level in which it is in foundation. So the total quantity of that, the two values, is going to give us disposal, because this what we dispose, the area we as in the blinding and ground beam together to give us disposal. So with that, we have there's no need to stress ourselves by start to calculate for disposal. So we've already know how to calculate for our disposal. So after doing that, the next item. So I want us to respond. I want to ask this question, please. So the next item is what? I want us to respond. After all this, the next item is what?
Surface treatment.
Surface treatment. Actually, you should have already calculated for surface treatment before even blinding. So if you want to calculate for surface treatment, we know that surface treatment, you can get surface treatment by earthwork support. You can also calculate for earthwork support. So if you want to calculate for earthwork support, so we copy this trench excavation too. We copy it and click paste. Choose second option and click OK. We want to calculate for earthwork support. So it has copied. I will double click on this copy trench excavation and change it to earthwork support. Earthwork support. We all know that earthwork support is optional depending on the nature of the ground. If the ground is solid and we have a good area, actually it won't be solid. Actually, that's why they introduced Raft foundation. So they might want to do earthwork support to retain the excavated materials. So earthwork support, after inserting that, so we click on Advanced. We all know that our earthwork support is measured in square meter. So earthwork support is to support the faces of our trenches. That is by multiplying all our quantities by 2. We only need the total linear meter and the height of our trench. So by 2, know that the plank is going to support one face and the other one is going to support another face, which it makes 2. So I will remove this width. We don't need it. So I will retain the depth and multiply by 2 face by 2 and change the quantity, the unit to square meter. So that's our earthwork support. I've gotten our earthwork support. Hope you got it. Do you understand?
Yes, I understand.
So having calculated for our earthwork support, the next thing is surface treatment. We all know that surface treatment is equal to earthwork support plus level and compact. Surface treatment is equal to total quantities we got for earthwork support and that of level and compact. So having gotten the two values, so there's no need to start calculating for surface treatment. So we just add the earthwork support plus level and compact. So that's our value for surface treatment, because the reason being that earthwork support, if we want to treat our trenches, we are going to apply the anti-termite treatment to the both faces of our trenches, same as the bottom of our trenches. So it makes it so all those things makes earthwork support and level and compact. So the two values is going to be summed together to know our surface treatment. We hope we are following.
Support you.
It's only one person that's responding. Others are they are keeping notes. Hope you all understand the way I explain how to calculate for surface treatment. I want another person to be responding. You should all be responding, please. Okay. So having done that, so the next item is what? The next item is what? If we want to do form work, we can still use our quantities to know the total area we want to do form work. But if you want to use this, we have to deduct for all these points. We are going to deduct all these points by knowing the total numbers of all these points. So I want to use these quantities again to know the total area we are going to board. So I can use these quantities I got for my ground beam, concrete ground beam, and click copy, click paste, click OK. So it has copied. I will just double click on it and rename it to form work to site of ground beams. So I have to change the properties by clicking the advanced. So in our ground beam, you know that we only need the total length and the height of our ground beam. So I'm going to remove this width because it's not needed. So the height and 2 by 2. We are going to board our external face and internal face multiplied by 2 and change our unit to square meter. Click OK. So this is the quantity for our form work. But mind you, we never deduct for all these points. We are going to deduct for all these junction, all these points, because without doing that, it will lead to over measurements. So I'll pick measuring to count to. I'll click count to. So I click this count to know the total number of my points, column points. So column points, click OK. So I'll be clicking it one by one. One of the point, which is 0.23. So I will double click on form work again. So I'll click on advanced. So I will bracket all this value, already gotten value. I will house it, do the bracket it and deduct, click minus. So having clicked minus, the total point to deduct is 39 number. So open bracket, 39 multiplied by the height of our ground beam is 1.8 and the width. So the width is 0.23 multiplied by 1.80. So close brackets. So I'm deducting 39 by 0.23 by 1.8 from the quantity I got for formwork to side of ground beam. So having computing this, I'll click OK. So you see the quantities of our formwork has reduced. It has reduced. So this formwork, it was 80 something before, so it has reduced to 79.3.9. Because if we don't deduct this, it's the amount of over measurement, especially if you are working as a consultant quantity surveyor. So you have to deduct. Do we all understand it, or I should come again?
I understand it. It was well understood.
Okay. So after that, we are going to calculate for reinforcement for this ground beam. Reinforcement for this ground beam. But before moving to that, to reinforcement, because reinforcement used to take a little bit time, as in this to take time compared to others. So let us calculate for filling, sand filling. So if you want to calculate for a sand filling, you just know the area, this area. So we just click on this area. So we click sand filling. Click OK. So we come from the, take this internal face. Take it sand filling. And there are some people, they used to calculate their sand filling in cubic meter. Some used to live in square meter by stating the thickness. So let us convert to cubic meter. So by double clicking on this sand filling, let's assume our sand filling is 300 mm thick. So we are going to multiply our quantities by 0.30 and change the unit to cubic meter. Click OK. So it has changed the quantity to 103.7 cubic meter. So after our sand filling, the next item is level and compact. Again, after doing the sand filling, they are going to compact it by using roller. Is it rolling machine? They will roll it to compact it. So we are going to compact this area to receive damp-proof membrane and blinding. Damp-proof membrane and blinding. So instead of us to start calculating again, so I will just copy this sand filling to know the quantities for level and compact of my bed. So I right click on this, click copy, right click paste, choose second option, click OK. So it has copied. I will double click on this copied sand filling. I will change it to level and compact bed. So I'll change the properties by clicking advanced. So I will remove this thickness because level and compact is measured in square meter. So change the unit to square meter. So this level and compact to bed. So after doing that, we are going to lay our damp-proof membrane. Our damp-proof membrane is going to be laid. So damp-proof membrane, quantities of damp-proof membrane is equal to quantity of our level and compact. Because where we compact, we lay our dam-proof membrane. Hello, hope you are all following.
Yes.
Are you following?
Very well.
So
very well.
The area we are going to level and compact, that's the area we are going to apply our dam-proof membrane. So there's no need to calculate for that. We just take note of that and take the quantities we got for level and compact to bed for our dam-proof membrane. So after our dam-proof membrane, we are going to apply blinding. We are going to apply blinding. So same quantities applies to our blinding by copy this sand filling, copy, click paste, click second option, click OK. So it's copy. So it has copy. So we double click on this copy and change it to, let us assume our blinding to be 50 mm thick. So 50 mm thick blinding to bed. So don't forget to change the properties by clicking this advanced, and change this thickness to 0.05, which is thickness of our blinding, and click OK. So we've gotten our quantities for blinding to beds to be 17.3 cubic meter. So after doing that, so the next item is, we've not calculated for reinforcement in ground beam. We are coming to that. So the next item is reinforcement to slab. So I will jump that reinforcement too. So I will jump that one too. We'll come back for that. So having done that, hello? After doing that, we are going to do concrete slab. So let us check the thickness of our concrete slab. Concrete slab. Concrete slab. So the thickness of our concrete slab is 400 mm thick. This is the thickness of our slab, 200 mm thick. It's 200 mm thick. So you can use this area of our sand filling to calculate for concrete slab. So by right-clicking on this sand filling, so right-click, so total quantity for our ground slab is 79.6 cubic meter. So
please, I have a question.
Okay.
I'm sorry, I hope I'm not interrupting.
No.
All right. Please, I think we're going to build subdeduction, for the ground beams. Because it's coming up already, right?
Ground beam. To deduct.
Oh, sorry. I understand. Don't worry. I get it now. I've gotten what I wanted to ask.
And the reason why we didn't deduct for all this, we use these values of our trenches for our ground beam. There's no need to deduct because I've already, my measurement is being taken from one point to another. I didn't take it all through like this. When I was taking this horizontal length, I started from here, take it like stop here. So there's no need to deduct. Adding that I took the dimension all through like this, I have to deduct all these points. Another way to calculate for our ground beam, some used to take, they will start taking the length of all this one. But me, I don't like doing this, by knowing this, all this length, taking all this length, because in some cases, the extra structural engineer used to miss some beams. They used to miss some beam. If you don't take note of that, they used to miss some beams. So I prefer using the trench excavation values. Since if I take this, there's no need, as in nothing will be missed by taking this trench excavation instead of using this details the DDF by taking it one by one. You can use this one, but I don't like that. I prefer using my trench excavation value.
Okay. When you said we were doing the raft foundation,
Okay.
I was thinking we are going to do bulk excavation. Do the bulk excavation so that we can get the total area of excavation. Then we apply the blinding. Later on, we calculate the beams and all those ones, because it's not like the normal traditional straight foundation that we normally do, whereby we do the hardcore filling and everything. So with the raft foundation, when we cast the concrete for the whole floor, it will cover all the beams. After we've done the beams, we cast the concrete, so all of them will be covered. So we don't need to do hardcore and all those things. That's for raft foundation.
Okay, is that your question?
Yeah.
Okay, raft foundation. If you look at this plan very well, raft foundation, there's nothing like bulk excavation. Where bulk excavation is needed, maybe they want to do the swimming pool, they want to construct underground tank or all those things. Or if we have pad foundation, if it is strip and pad, so pad area will be bulk excavation, which is pit excavation. But in this case, is the difference between strip foundation and raft foundation is just the ground beam. That's the only difference. Ground beam is the difference of strip and raft foundation.
Okay.
Did you get me?
Yeah.
So here is just strip. Let me just say it's a strip with ground beam. That's raft foundation. So if you are starting to calculate for bulk excavation, that's another thing. There's nothing, according to this plan, there's nothing like bulk excavation. If you are doing bulk excavation, that means the whole area is going to be concrete. And there's nothing like this based on this drawing.
Okay.
You need to know the total length in which our concrete our ground beam is going to be situated. So are you clear now?
Yeah.
So any other question?
Yes, sir.
Okay.
All right. While I can say I am clear with everything you've done so far, and I want to thank you for that. So the only thing is how to introduce, I think I missed it, how to introduce the plans. So how we can bring it inside the Planswift. So that's where I missed. Exactly.
Okay. Okay. Any other thing?
No. I got other items.
So if you want to import drawing from external files to Planswift, first of all, you will click on this name. So having clicked on this name, it brings this. So the first column says job codes. Maybe you can name your job with any code. So let me name it with, my name is Taiwo. Let me name it Taiwo. That's my job code. So description, what do you want to do with that project? What do you want to be? Description of that project, maybe it's a proposed residential development for Mr. A at so location in so state. So that will be your description.
I've gotten the answer to the question. I tried it now and it worked. Thank you.
Okay, so there's no need to try to.
Yeah, exactly. Okay. Exactly. I don't want to waste your time, please.
Okay. So let's calculate for ground beam reinforcement. So before we move to to that. So this shows details for our iron for ground beam. So we'll be taking it one by one. So we take, we may not be able to take off for all the ions. So we just take some for our understanding. So if you look at this section of the iron, the top bars, the total number of ion they use for top bars is 4 number of Y16. They use 4 number of Y16. So for the bottom, they use 2 number of Y16. For the side, they use 4 number one side. They use 4 number the other side, making 8. So now, if you want to know the total running length of Y16 in this beam 100, this beam 100, beam 100, beam 101, beam 102. Hope you are all following. Hello? We have beam 1, we have beam 100, beam 101, beam 102. So the total number of Y16 they use on this beam, for top they use 4 number, for bottom they use 2 number, making 6 number of Y16. So let us take up for that. So I will click on this linear. So I have to scale because this is the new page. I have to scale this page again. So I click yes. So I will take any of these dimensions for my scale. So let me take 4.20. I will click OK. So my 4.20 is from here to here. So let me cross check whether that is correct by clicking this dimension and take this. So it's correct. So now I want to know the total quantities of my reinforcement in this beam. We have 3 types of reinforcement in this beam. The first one is Y16. Sorry, 2 types. We have Y16 and Y10. Y10 is the link. So let us calculate for Y16 first. So I will click on this linear meter. So I will click Y16 ground beam 101. Sorry, ground beam 100, 101, and 102. So we are going to click on advance. Don't forget that total number of Y16 in this ground beam 100, 101, 102 is 6 number. Sorry, not 6. We have 4 at the top, 2 at the bottom, and 8 by the side. So 4 plus 8 plus 2. We have 14 numbers, total number of Y16 in this ground beam. But the ones by the sides, they are smaller than those ones at the top and at the top bottom. So we are going to consider the ones at the top and at the bottom because those ones have bent. The ions at the top, they have bent. Y16 at the top and Y16 at the bottom, they have bent. But those ones by the sides, they don't have bend. So we are going to consider them separately. So the first one we are going to consider here is those Y16 that have bend. So I will click on advance. So I will multiply my quantities. We know that the total number of bent Y16 is 6 number. We have 4 at the top and 2 at the bottom, making 6. So we are going to say multiply by 6, and the weight of our Y16, the density of our Y16 is 1.577 kg per meter. If we want to convert our measurement to kg, are we all following? Hello?
Yes.
So if we want to convert our measurement of Y16 from meters to kg. So we are going to multiply these our quantities by 1.577. So how did I get that? We all know how to get that. So
Exactly.
we all know, so there's no need. So by 1.577, some used to round it up to 1.578, but I normally use 1.577. So 1.577. So we change our unit to kg. So kg is not, the units of kg is not on the list computed inside this Planswift. So we can just write it. After writing the kg, we click enter. So after clicking enter, we click OK. So we now take our measurement. So apply my quantity by 6. We have 4 at the top and 2 at the bottom, making 6. So the total quantities for this one is 149.5 kg of Y16, of bent Y16. So having known that, remaining the straight Y16 by the side, the one by the side, we have 1, 2, 3, 4 on this side. We have 1, 2, 3, 4 on this side, making 8. So once again, we click on linear. We write Y16 GB, which is ground beam, 100, 101, and 102. And click on advance. And again, write the total number of that Y16, which is 8. Multiply by 8, multiply by the density 1.577, and change the units to kg and click OK. So those one will be, this one are these straight ones. So that's straight Y16. So that one is 170.3 kg for this ground beam. So for our links, if we want to calculate for our links, you know, our links is here, the height of the beam and the width of the beam. So you click linear. So, sorry, first of all, what is the spacing? Okay, spacing is 200 mm. So what's the length of this beam? So the length of this beam is 13.47. Or we can cross-check, you can try to dimension the total length. So the total length of this beam is 13.45. So 13.45. So let us know the get of our link first. So we'll click on this linear. So you say Y10 ground beam 100, 101, 102. So we all know that the total length is 13.45. So we click here. You say multiply by. So whatever quantities we get, we are going to multiply by the total number of link in that ground beam. So the length of a ground beam is 13.45. So don't forget to bracket this. So we are going to divide it by the spacing, which is 0.20. Multiply by the density of our Y10. So density of our Y10 is 0.616, 0.616, and change the unit to kg. So after doing that, we click on OK and take this to know the get of our link. So that's get of our link. So the total quantity for our Y10 is 165.7 kg inside this gram beam. Do we understand how I got this link?
No question yet.
So, and I remember something. I just remember something now. The quantity we got for our form work, you know that I use height of gram beam, which is 1.8. Actually on site, it's not going to be exactly 1.8 because, you know, when they are budding, there's going to be projection of iron whereby slab reinforcement is going to be attached to. So we suppose less 200 mm thick of slab, because if they are budding out of 1/800 height of the ground beam, they are going to less 200 thickness of slab, because the budding is not going to be full length of 1.8. Are we getting me? Beam and change the height to 1.6 after deducting 200 of thickness of slab, 1.6, because they are not going to board the whole length, the whole height of the ground beam. They are going to leave 200 mm for slab. So we hope that is clear.
It's okay.
Okay. All right. As I was saying, I say what we are going to do today is to create templates for our measurements, plugins. So whenever you want to create plugins on Planswift, first of all, you will click on templates. So I click on templates. Having clicked on templates, I will click on new tab here. Please be following my cursor direction so that you will not be confused. So after clicking on template, we click on new tab. So new tab brings this to inside the name I want to name my plugins. So I want to name it substructural elements, since all the plugin we want to create is for substructural elements. So substructural elements. So I'll click OK. So it has created. You can look at this list of the elements here. Substructural element has been created. So now, as I said yesterday, that there's no need to create plugins for site clearance or site preparation, because that one is a direct measurement, just to know the area. Once you click on area tool on Planswift, so it will give you the area of your site. So there's no need to create plugin for that. So we move to trench excavation. So as I explained yesterday, that whenever you want to calculate for trench excavation is to take linear tool or segment tool. So I would like to pick linear tool here. So I've clicked on linear tool, it brings this property. So I will name it trench excavation. Trench excavation. So, and trench excavation is measured in cubic meter, and the tool I choose is in linear measurement. So I have to adjust these tools to make it to change the measurement to cubic meter. So by clicking on advanced. So having clicked on advanced, so I need two things to complement my quantity, which is width and depth. So I have to create that column for this. Hope you are all following. Are we hearing me? Are you hearing me? Sorry. Are you all okay?
Yes.
I'm following. Okay. So we need two things to make our trench excavation, which is width and depth. The width and depth is not yet inside this property, so we have to create that. So if you want to create column for width, you have to click on this insert property. So I will click width and click OK. The next thing is to create column for depth. I will once again click on insert property and click depth. right depth. So now we have gotten our values. So the next thing is to multiply this our takeoff by the weight and the depth. So we click after this takeoff in front of quantity under estimating and click on this multiplication tool here and drag this width to that column by holding down our left button on the mouse and drag it to the front of the quantity. And once again, click on multiplication sign here, drag the depth to the front of quantity inside quantity column. So to make our measurement in cubic meter and change the unit to cubic meter. So I want to check depth and width. Checking is that I want to be seeing them because the depth might change. Maybe I want to use this tool for another drawing. So, and the depth of that drawing might be different from this one. So I have to check it to be seeing it in case I want to change the depth. And I have to check the width too. So there are some other items under this field that have been checked. So I don't need them, I have to uncheck them. So I'm trying to uncheck all these ones because I don't need them. So I've already checked those ones that I need. So I change this unit of our depth is in meters. Unit of our width is in meters too. So after doing all these things, we are going to click on form layout. Form layout. So having clicked on that, it brings this form layout. So the first column says name, second one says show units, and third one same row, fourth form tab. So I have to show the unit of this my parameters. So having done that, I'll click OK and click OK here. So I've created a plugin for my trench excavation. I've created a plugin for my trench excavation. So now look at, there are some items that are dependent on the total linear meter of our trench. As we did yesterday, first, level and compact is dependent on trench excavation linear meter. Earthwork support is dependent on total linear meter of our trench. Backfilling is dependent on trench excavation. Disposal is dependent on trench excavation. Blinding also is dependent on our trench excavation. So also the ground beams. All these items, they are dependent on the total length of our trench excavation. So all these dependent items, we have to link them with this trench excavation we have created. So how are we going to do that? So if you want to link all these items with this trench excavation we have already created, we click on this new parts. So it brings these properties. So the first item we want to create is level and compact, because after we have excavated, the next thing is to level the bottom of our trench to receive blinding. So the first item to create is level and compact. Level and compact. Hope we are all following. Sorry, I need to be confirming. Are we all hearing?
Yes,
following?
yes.
Okay.
Yes,
so
yes, loud and clear.
Okay, having created level and compact, we click OK. I click OK. You know, this level and compact is a sub-item to trench excavation because level and compact is dependent on this trench excavation. So we have to make it move inside. I want to move this level and compact icon inside. So by clicking on this, if you look at the right side of the screen, see my cursor, the move right arrow, I have to click on that arrow, the move right arrow, if you look at the cursor. So I click on it. So, you know, the level and compact has been embedded, that's been inside the trench excavation. So having done that, you double click on this trench excavation. Double click on it, click on advance. So it brings this. So as I said earlier, that level and compact is going to be dependent on trench excavation in such a way that whenever I measure for trench excavation, automatically my level and compact will be generating. The quantities for my level and compact will be generating. So how am I going to do that? is to link the total quantity from my trench excavation to this place. First of all, level and compact is measured in square meter, but trench excavation is measuring in cubic meter. So I have to create column for width here, for width, in order to complement my quantities to make it square meter. So I have to click create column for my width. So I will click width and click OK. So column for width has been created. But you know that I've already created width under trench excavation. So I don't want to be typing the width once again. So I will just link the width under trench excavation to this width under level and compact. So if I want to link the width under trench excavation to this width under level and compact, I will click on these 3 dots in front of this width and click on this first icon. So I will click on this trench excavation I've created. So on this list under shows, I will look for width because the width I've already created is going to show here. So I will look for width. So the width as shown, I will click on the width and click OK. Click OK. So I link it so that whatever I input, whatever value I input for trench excavation width is going to be automatically effective for level and compact. So that's one. Second one is to link the total linear meters I measure for under trench excavation. So how am I going to do that? So I'm going to click in front of this quantity and click on these 3 dots once again and click this first icon inside property. Click on this trench excavation. So I will search for total linear or takeoff. The total linear is where all our quantities we take off for under trench excavation is going to be recorded. So I will look for total linear here, total linear, total linear, or linear total. So I've seen linear total. I will click on it and click OK, and click OK. So I've linked my trench excavation with my level and compact. So the next thing is to multiply my quantity with my width, since level and compact is measured in square meter. So in front of this quantity under estimating, I will click on this multiplication symbol and drag this width to the front. Actually, the multiplication symbol has been removed. So I will click on it again. So, and change the unit to square meter. Square meter, the unit for width is meter. So I have to check. So no, there's no need to check this since they have already linked this width to trench excavation. Whatever the width of trench excavation is, that's what this width is going to be. So there's no need to check this. So whichever one that's check, I have to check this. So having done that, or you can decide to check it actually. So having done that, you click on OK. So let us now check what we've done for this trench excavation and level and compact, whether we are on track. So let us measure. So if you want to go back to home, you click on this home. Sorry, this architectural drawing. Okay. So let me hide this. So I want to use this our plugin, the one I created, so structural elements to take up. So first of all, I want to take up for trench excavation. I will click this one. I will not click on this tool again because I've already created my own plugin or custom tool by the right hand side here. So we click on this green circle in front of this trench excavation. Hope you are all following. Are we getting me? Are you getting me? Sorry. Are you getting what I'm trying to explain?
Yeah, yes.
So I should go on, Abby. Okay, so you click on this green icon. Having clicked on it, it brings these properties. It says I should insert my depth. What's the value of our depth? The value of our depth yesterday is 1 meter and the width is 0.68. 0.68. So I will click OK. So I'll be taking it. So if you look at this last item, you see the trench excavation has been taken off for. So also level and compact. You see the same values, they are the same. They are the same because the depth is 1 meter, is meaningless. The level and compact is a meter square. The trench excavation has been calculated for. Level and compact has also been calculated for concurrently. Do we get it? Do we get it?
Yes. Yes.
So,
Yeah.
Yes.
now that we have confirmed this, so let us go to next item, the independent next item, which is blinding. You know that after level and compact is to blind. So we go back to our template. We go back to our template and click new parts again for our blinding. So we write blinding. Blinding. And click OK. So the blinding has been created. We double click on the blinding and click on this advanced. So for our blinding, we need total linear meter we calculated for trench excavation. We need width of our trench and the thickness of the blinding. So once again, we have to create column or row for our width and thickness. So I will create another row for my width, click OK, and again thickness, click OK. So since we've already know our width from our level and compact, so or from our trench excavation, so I will just go there and copy that width by clicking on these three dots. Click this one, click on this trench excavation, and look for my width. So this width, and click OK. Click OK. So for my thickness, there's no thickness yet for, as in we've not created our thickness. So we just type, since we know our thickness, just type 0.05 for our thickness. So another thing to copy from our trench excavation is the total linear meter, because we need our total linear meter to know the total running length of our trench for blinding. So we click in front of this quantity and click on these three dots, click on this first insert property, click on this trench excavation. So we look for our linear total again, linear total. On this list, we look for linear total. Linear total. Okay, this linear total, and click OK. Click OK. So having done all this, we have to drag our width and thickness to multiply our quantity. So we multiply this by width, multiply by width, multiply by thickness, multiply by thickness. So change the units for this one, meters, this one is in meters, this one is in cubic meter. It's in cubic meter. So now I have to check my thickness, because I'm checking thickness because it might change. It might change. Some specification used to say 100 mm thick blinding. Some used to say 150 blinding. So I have to check it in case it changes. So I have to check by marking the front. So let me look at other things, whether there's no other items that is checked. So no other item that is checked. So I will click on this form layout. So I can check the width too. Form layout. I click on this form layout, click on this show units. So everything has been shown here. I will click OK. I will click okay too. So let us now go and check whether what we did is in order. So before we check, we have to delete what we've done already so that will not mix up. Because as we are checking, we'll be taking off our trench. So let me use this tool to measure for our trenches. So I might not measure, okay, let me measure everything. So trench is gain. So the depth remains 1 meter, and our width is 0.68, and click OK. So the reason why I'm checking one by one, so that I will not go far and later discover that what we did for certain elements is not okay. So that's why I'm trying to check as we are creating one item, we are checking. So we are checking. So let me just check. There's no need to take off words. Let us use this one and check. So we see now the quantities for trench excavation has been generated. Quantity for level and compact has been generated. Quantity for blinding has been generated, which is 2.89 cubic meter. So if you want to see all these things, you can click on this estimating. You can click on this estimating. So to show all these parameters, you see level and compact, this is the unit, blinding, 2.89 cubic meter has been generated. So having done this, the next item to link with our trench excavation is earthwork support. Our earthwork support. So we once again click on this template. So having clicked on this template, we click on this new part. Click on this new part and write earthwork support. Earthwork support, and click OK. So earthwork support has been created. So we double click on this earthwork support and click on this and pass. So we know that our earthwork support is measured in square meter. We only need total running length and the depth. Total running length and the depth of our trench. So since there's no row for depth yet, so we have to create row for that depth. So we click on this insert property and create row for depth. Click OK. So since our trench excavation has depth already, so we are going to link that depth with this our earthwork support. So by clicking in front of this depth, clicking this one and click on this trench excavation and look for depth. Look for depth on this. So these are our depths and click OK. So don't forget that depth, our earthwork support is going to be to the two faces of our trench. So the depth is going to be multiplied by 2. So multiply by 2 and click OK. So we go in front of this quantity and link our total running length from trench excavation to this earthwork support by clicking these 3 dots. Click this first item, click on this trench excavation and look for our linear total or take off anyone. Linear total. Okay, these are linear total and click OK. Click OK. So we multiply our depth by this linear total by clicking this multiplication icon and drag this depth to the front. So let me check this depth. Change the unit to meters. This one to cubic to square meter. So having done that, go to form layout, check the units, check the unit, click OK, click OK, click OK. So we have created plugin for earthwork support. So let us go and check again whether what we did is in order. So we go back to home. Let me delete the one we did earlier so that I will not be confused. So I will pick trench excavation once again, input the parameters. here and click OK. So you see now, everything has been generated. You have quantities for trench, you have quantity for level and compact, you have quantity for blinding, you have quantity for earthwork support, same time. You see how this one is easier compared to the way we did yesterday by using the Planswift tool. So the next thing after earthwork support is our ground beam or surface treatment. You know, I said yesterday that surface treatment is equal to total quantities for level and compact and earthwork support. So the summation of the two values is going to give us surface treatment. So there's no need to calculate for surface treatment again, having known the level and compact and our earthwork support. So let's do backfilling. Let us do backfilling before moving to ground beam. So once again, I'll click on template. I will click on template. So click on new parts and write backfilling. And write backfilling. So, and click OK. So we double click on this backfilling. I click on this and pass. Having clicked on this and pass, so we need depth for our backfilling. We need depth for our backfilling. So we create column for our depth. But depth we need for our backfilling. Okay. We need depth and the width. So I will create column for depth. Okay. And create column for my width. For my width. Okay. So, you know, as I said earlier, that the total width of our trench is 680. The total width of our trench is 680. So the size of our ground beam is 230 by 1800 mm. That is, the width of our ground beam is 230 mm. So if we deduct 230 mm from 680, we are left with 450 width to backfill. We are left with 450 width to backfill. So we will link up with trench excavation for this depth by clicking on this. Click on this, click on the trench and look for our depth, and click OK. Click OK. So also for our total running length, trench excavation, linear total, we look for linear total. Click OK. Click OK. So for our width, you know, our width is not yet created. We don't, as in, there's no value for our link under trench excavation. We only have 680, and we cannot use 680 for our width for backfilling. So how are we going to do that to link that? So we can do that in two ways. Is by we have to link the width of our trench with this width and divide it by 3. You know, if we divide 680 by 3, 680 by 3, we are going to get like something 226 or 227. So having done that, we multiply it by 2. We are going to multiply it by 2. So we are going to get value for our width. So I would like to link this my width with that of trench, and look for width This is my width and okay. So I will divide by 3, meaning out of 680, one part is for ground beam, one part is to backfill external face, one part is to backfill internal face. So after dividing by 3, I will now multiply by 2 to cover for the 2 sides. So I will divide by 3. I will close the brackets and multiply by 2 and click OK. So to get our cubic meter, I will multiply my quantities by this width by dragging this width to this front. Multiplication, drag this depth to the front, change the unit to cubic meter, this one to meters, this one to meters, and check these 2 items. Let me look whether there's no other item that's checked. So having done this, I will click on form layout. I will like to show the units of this and click OK. Click OK. So we have created plugin for our backfilling. So let us go and check again whether what we did for all these our items are in order. So let me delete the one we did earlier. Okay, so I will click in front of this trench excavation once again. So input the required parameters. And click OK. So let me check. So as we can see, all our parameters, all our quantities has been generated for trench excavation, for level and compact, for blinding, for earthwork support, for backfilling. That means we are in order. We are in order. So the next item is disposal. So there's no need to calculate for disposal again, since we've no quantities for trench excavation and backfilling. It's just to deduct backfilling from trench excavation. We are going to know our value for disposal, or we sum up the total quantities for our blinding, total quantities for our ground beam in foundation, and sum the 2 together to know the total quantities for our disposal. We can use either of the 2 methods. So there's no need to calculate for our disposal again. So the next item is ground beam. So let us calculate for our ground beam. Since our ground beam is dependent on our trench excavation, because our ground beam is going to be along the trenches, throughout the trenches. So let us go back to template. Hope you are following, please. Are we all following?
Yes. Yes.
Okay. So let us create a new tab for our ground beam. So by clicking on this new part. So ground beam, click OK. So double click on this ground beam, click on this advanced. So for our ground beam, we need the total running length of our trench. We need the width of the ground beam, and we need the depth, that is thickness of our ground beam. But unfortunately, there's no depth or thickness of our ground beam on all what we've done to link up with these properties for ground beam. So we have to create column for width and thickness. I don't want to call it depth, because the thickness of there's nothing like depth when dealing with concrete. Is thickness, the width and thickness of our ground beam. So let me create a row for that. So first of all, the width of our ground beam. The width, okay. The next thing is thickness or height, whichever one you want to use, and click OK. So I will drag the total linear meter for my trench excavation to these properties for ground beam by clicking this and click on this trench excavation and look for my linear total. Linear total. So this linear total, and click OK. Click OK. So having done that, I will multiply my linear total by the width of my ground beam, and thickness, and my thickness. So I want to input some parameters for my thickness. So I will double click on this thickness. So once I double click to bring this, so inside this white space, we know that thickness of our ground beam is 1.8. So assuming we are working with another drawing and the thickness of our ground beam is 450, 230, etc.
I think.
So, hello?
Yeah, I can hear you.
Okay, hope you can see the screen. Is the screen showing, Sha?
Yes.
Okay. Okay, as I was saying on ground beam, I'm sorry for the little delay. There was a little bit internet problem here. So as I was saying, for our ground beam, having created a new part for our ground beam, so I will double click on the ground beam. Click on advance. Okay, we've created width and thickness. But unfortunately, we never know our parameter for thickness and width. So I will change this unit to cubic meter, the thickness meters, the width meters. Sorry, let me change the thickness to height. The height of our ground beam. Okay, so I will check the thickness, the width, and so I want to include some parameters under this height. I will double click on this height, so it brings this. So in case maybe we are working with another drawing whereby the height is not as higher as this, so I will just input and predefine the quantities for this ground beam, possible height of a ground beam. Some used to be 0.23, 0.445, 0.6, 1 meter, 1.6, 1.8, 0, and click OK. So also the width, double click on the width, input predefine 45, 0.5, 1.00, click OK. But for this, the height of our ground beam is 1.8, so I will just choose 1.8. The width is 0.23. I'll click on 0.23 for this one. So having done all this, I will click on form layout. Form layout, check the unit and click OK. Click OK. So now we are done with ground beam. So let's go and check again. So let me delete this one. So by clicking this, and the depth is 1 meter, the width remains 0.68, and click OK. So let us check. So we can see now the quantities for our ground beam has been generated to be 35.2 cubic meter. So let me take up for all this for all the trenches to compare with what we did yesterday, whether we are going to get the same quantities. So let me take up for the whole quantities to compare with the one we did yesterday. The difference between them is 0.23, and the difference is negligible. It's not that, it doesn't have any impact. If you look at the level and compact, it's also 153.23. Blinding, 7.66. If you look at the blinding we did yesterday, where's the blinding? Blinding we did. Okay, this is 7.65. You see, difference was 0.01. Network support 450, you get 451. So no difference. Gram beam 93.29, gram beam 93.15. So you see the closeness of the quantities. So there's no much difference between the quantities. So having done this one for gram beam, we go back to our template. So the next item that's dependent on trench excavation. So the next item that's dependent on trench excavation is formwork to ground beam. I want you to take note of one thing. You know that our ground beam, the height of our ground beam is 1.8, and the thickness of our slab is 200 mm, as I did earlier. So we have to deduct that 200 from 1,800 mm height of our ground beam, because when they are going to cast, they are not going to cast, or when they are going to board, they are not going to board the whole height of the ground beam. They will leave 200 mm space for reinforcements for slab to link, as in to have link with ground beam reinforcements and that of slab. So they will not board the whole length. They will leave 200 mm thickness of the slab. If the thickness of slab is 150, they are going to leave 150 mm thickness from body. If the thickness is 250, they are going to leave 250 from body. So the height of our ground beam, as we see yesterday, the height of our ground beam, you see now, the height of our ground beam is 1.8 and the width is 230. The thickness of our slab is 200. So we are going to less 200 from 180 to know the height of our formwork to ground beam. So let us go back to template. So for formwork now, it creates new parts. New part. So formwork to side of ground beams, click OK. So we double click on it and click on advance. And we need, what do we need? We need depth, we need height of a ground beam. So since formwork is measured in square meters, so we have to create row for our depth, for the height of a ground beam. So height and click OK. Since we know our value for height for underground beam, so we are going to link this ground beam height with this formwork. So I'll click on this and click this. So instead of me to click on this trench excavation, I'll click on ground beam because the height, the depth I need is underground beam. So I will click on this ground beam and search for height. Search for height. This is the height. And click OK. Click OK. So you know the height is going to be to the both sides. So I'm going to multiply by 2. Our formwork is going to be to the both sides of our beam, multiply by 2. So for quantity, I will link my quantity with total linear under trench excavation. Total linear trench excavation. I will look for total linear total mean, and click OK, and multiply by the height. Multiply by the height. This height. Multiply by the height. And don't forget, sorry, this height, I cannot link with this height because our height is going to be reduced. So I will say minus whatever height minus 200. I will say minus 200. 200. Since the thickness of our slabs.
I even think that's even negligible. Like the quantity is not that much.
But just to follow the standard, actually, to follow the standards. Or we can leave it, we can decide not to deduct it actually. So let us leave it. So you have multiplied it by the height. So and we know that we have column junctions, other junctions, column junctions, and all that. We are going to less it from these our quantities. And we know that all the junctions we calculated for yesterday, they are all 39 numbers. So we are going to bracket this and minus open brackets by 2 by the width of our column. The width of our column is 230, so we have to create space for that too. Width of our column width. So column width is, let me predefine it. So we are going to multiply it by the column width and the height, which is 0.23, by this column width, same as the height, multiplied by the let me go and copy the height because I've already multiplied this. Okay, I've already multiplied this height by 2. So let me go and copy the height under trench excavation. Sorry, underground beam. I mean, ground beam height. Okay. So I close the brackets. Okay. So this one is in meters. This one is cubic meter. Sorry, meter square. This one is in meters. So I will check the two of them. Check the form layout. Show the units. And click OK. And click OK. So let's check whether this is correct. Let's check. So let me delete this one. So let's check for this formwork. 0.68. Okay. So let me check. So it has been generated. All the quantities has been generated for level and compact blinding, earthwork support, backfilling ground beam, formwork to ground beam. So I think these items, they are the only one dependent on trench excavation. No other item that's dependent on them again. So having done all this, are we getting me, please? Are you getting me? I'm sorry. Are you getting me?
Yes,
You are
yes.
following. Okay. So having done this, we go back to template. So the next item to do is sand filling. And we know that sand filling is measured in square meter. So definitely, we cannot link sand filling with trench excavation. We cannot link sand filling with trench excavation. So we create new tool, which is area tool. We pick area tool and write sand filling. Maybe the first thing we want to do is sand filling. Sand filling and create OK. Double click on advanced. So for our sand filling actually is measured in cubic meter by multiplying our quantities with thickness. So thickness of our sand filling, let's assume 300 mm thick. So we can predefine that too, whichever one. In case we have other drawing that states different thickness. So click OK. So now multiply our thickness by the takeoff. Multiply by this takeoff. Change the quantity to cubic meter. Cubic meter. The unit for thickness is in meters. So thickness, let us choose 300 mm thick. Let me check this. I don't need all these ones. So I have to uncheck them. So uncheck them and click OK. So don't let us confirm this because this one is straightforward. It's going to be correct. So another item that's dependent on area of sand filling is perhaps adding that we are working with strip and pad. Normally they used to introduce hardcore filling for strip and pad. So strip hardcore filling is dependent on this one too. But we are not going to do for hardcore filling because we are dealing with Raft foundation. So another item that's dependent on sand filling is level and compact the bed to receive blinding. So we choose new parts. So level and compact to bed. To bed. Click OK. So we double click on it. Click on advanced. So we now go, we link sand filling area to this one. Since that the area, wherever we are sand filling, that's where we are leveling. We are going to compact. So we link the quantities with this one by clicking this, click this one, click on this sand filling, and we are going to look for area because we are dealing with area. We look for area inside this. We are going to look for this area. We click on area, click OK. Sorry. It's not going to work. So as I did earlier, we are going to click on this arrow as sub-item to sand filling. So before we do anything, if we don't do that, it's not going to work. So double click on it, link that area with from sand filling. Click on area, click OK, click OK. So that's what we need, and choose the units. square meter. You can check it if you like. So click on form layout. Don't have any other parameter. Click on OK. So let us check whether what we did for sand filling and this are correct. So for sand filling, the thickness is 0.3. Click OK. So sand filling to these areas. Okay, let us use this one to check. So we see now, sand filling, they have 21.99 cubic meter, level and compact, quantity 73.30. The quantities have been generated. So the next one that is dependent on sand filling is blinding to bed. Before we move to blinding, after they compact the bed, they are going to lay damp-proof membrane. So damp-proof membrane is also dependent on this area of sand filling. So we are going to click on template again. Click on new parts. So write DPM to bed. Click OK. Double click on it. Click on advanced and link our level and compact with this DPM. So click on this, click this, or we can link level and compact or sand filling, whichever one. So sand filling area. Click on area, click OK. Click OK. Change the unit to square meter. Check the form layouts, then no other parameter, click OK. So that one. So after the DPM, we are going to blind. We are going to blind on top of our DPM to receive reinforcements for slab, ground slab. So the next item is blinding to bed. Blinding to bed. Blinding to bed.
Even with a poor
Click
connection.
OK.
Light today.
Click on it. So, and now our blinding is measured in cubic meter. So we have to create rule for our thickness, for thickness of blinding. So thickness, click OK. So we can predefine this one too. In case it changes, it change. So 0.15, 0.05, 0.10, 0.15, 0.20. Click OK. So we now link our area from sand filling to this blinding. Sand filling, the total area here. Click OK. Click OK. And multiply this our area by the thickness of the blinding. So since we know the thickness of our blinding to be 50 mm thick, we just check that one, change the units, cubic meter. So check this, look for if there's any other things, click on this, choose the units, click OK, click OK. So we are done with blinding to bed. So the next thing is form work to our slab. Form work to our slab. So form work to our slab is not dependent on this our sand filling, because form work to our slab is going to be external face. It's going to be to the external faces of our wall. So we are going to choose another tool
for this. But before doing that, let's go and check whether what we've done so far under sand filling is correct. So let me go back to home. Let me delete the one we've done. Delete sand filling. Delete. So let me check under sand filling. You know the thickness of our sand is 0.30. Click OK. So sand filling is going to be here. Area. So let us check. So we can see now all the quantities have been generated for sand filling, level and compact to bed, damp-proof membrane to bed, and blinding to bed. So the next one is hello? Are we getting it?
Yes, yes.
Okay. So the next one, you should not forget column starter. There's going to be reinforcement for column starter. There's no concrete for column starter because concrete for ground beam has taken for our concrete for column starter. So there's no need to calculate for concrete for column starter. The only thing we are going to calculate for is for reinforcement for our column starter. So if you start to calculate for concrete for column starter again, that's going to be over measurements. Because as you are casting for ground beam, you are casting for column starter alongside. So there's no need to calculate for concrete for column starter again. So let us calculate for reinforcements for our column starter. So let us check our columns. Our columns. Trying to locate where the details of the column is. Detail. Okay. There no detail for it. Okay, these are columns. So we have column 1 to be 30 number, column 2 to be 5 number, and column 3 to be 1 number. So if you want to know, from here to here, these are column starter up to here. From here to here, that's the height of our column starter. So that's the height of our column starter. So let us scale this page by clicking on dimension click. So pick any of these dimension 3.15 and click OK. So let me cross check. This is not correct. Check. Check again. 1.80 from here to here. Check. Okay. So if you want to create plugin for our column starter, we will be needing the height of this our reinforcement and this bend. So let me check the bend. What was the bend? What was the height of this? The height Let me check the height. The height is like 3 meters actually. The height is 3 meters and the bend is 0.18. So let us go back to template. So I want to create plugin for column starter. You can use that one, this one for anything column. You can use it for column, but we are dealing with column starter first. So I will pick count 2. I will pick count 2. So it's count 2 that I want to use to measure this. So I will click on this count 2 and name it column starter, reinforcement to column starter. So I will click OK. So after clicking OK, I will double click on it, click on advanced. So what do we need to know the quantities of this column starter? So we'll be needing the length of the iron. So I will press row for length. Sorry, the number of columns. Okay. So the next thing is the length of the column. Length. What else do I need? The number of iron in a column. Quantity. So I'll be needing the weight of the iron. The weight, density, and the bend, click OK. So to know the quantities of our iron, so we create another row for sum, formation to sum up all the quantities for our column starter. So I will create sum. So under this sum, we'll be needing length, the length. I'll pick this length, drop inside of sum, multiply my length by the total number of my columns. Total number of my columns. Hello?
Hello.
Are you all getting it? Or we are lost?
Yeah.
Okay.
Now
I think if I want to know the quantities of my iron, first of all, you know the length. The length means the straight length and the bend. So quantity of iron is going to be the length, this length plus the bend. That will serve the quantities of my iron. So let me delete this. So I will drag this quantity of iron in front of this sum and multiply it by the total number of iron. Sorry, I never create number of iron. So let me create that number of iron. Number of reinforcements in a column. So I will drag this number of reinforcement in a column in front of this. So this will serve the total sum of my iron in a column. So after creating this, I will multiply this by the density of my ion. So let me predefine the density in case it's changed. Let me assume 0.88. Oh, okay. So the weight, let me predefine the weight too. 10, 12, 20. Click OK. So after doing that, the density is 1.577. The weight is 16 mm. So I have to multiply all my quantities by the density to convert it to kg. So multiply by density. So the quantity of ion is there already, length plus bend, multiplied by the number, multiplied by the length, and multiplied by the number of column. So I multiply by the number of column, which is this one. It seems all our parameters are in order. So after doing that, I will click in front of these quantities.
The weight, I was thinking it would be diameter. Then the density rather will be weight.
No, density is going to be 1.577 kg per meter. The weight of the ion, which is the diameter, is 16 mm.
Okay.
60 mm. So I will multiply this under this quantity by this sum. So I will do multiply by, I will carry all this sum in front of the quantity like this. So whatever I get is going to be in kg. I will change the unit to kg. kg. I will change the unit number of reinforcement to number, the bend to meter. I will check.
Sorry, the zoom.
So having multiplied all our parameters under this sum, so I drag the sum under quantities. So let me check whether all the parameters required has been considered. So quantity of our ion is there, length plus bend, multiplied by the number of reinforcements in that column, the density, and the number of column. So let me change the units, the length to meters, number of column into number. And what test again? This one weights to mm, 16 mm, and our density to kg per meter. Kg per meter. Click enter. So I will check all those things that I'll be needing. Check bend. I'll be inputting parameter for bend. The density, I can change the density, the weight. So I don't need to check this, the length. I will check the length. The number of column, I will check the number of column. Because they are items, they can change. So let me uncheck all these ones that I don't need. All these ones that I don't need. I don't need all these ones. So after checking all this, so click on form layout. So I want to show the units. I want the units to show. So I don't need this shape to be here. So I can drag it down like this. I want number of column to be the first item at the top. So I will click on this to move it upward, the length to be the second, click it to move it forward. Since they are in order now. So I want density to be in the same row with bend. So after the density, I will click this. Sorry, I will click this. So since they are okay like this, and click OK, click OK. So let us go and test what we created under this column. We are starting with column 1. So let me click on this reinforcement, this one. So it brings all these parameters we created. So for column 1, we have 30 number. So number of column is 30. The length of column starter is 3 meters, 3.0. The bend, as we measured, is 0.8, 0.18, 0.18. So the density, we have 16, is 16 mm. It's still okay. We forgot one parameter to bring the number of reinforcements. Okay, we have the number of reinforcements. Let me go back. We forgot one parameter. Let me double click. Fast. Number of column, number of reinforcement. You have to check this number of reinforcement too. You didn't check it. You have to check. Click on this form. Okay. So no.
What about the rod extension?
The
The rod extension. You see, it enters into the other
bend.
one.
That's bend. The
Okay.
rod. What do you mean by rod extension?
The lapping with the other rod.
Is there any lapping? Let me check. No, there's no lapping. We are considering the column starter.
Okay. The
Column
substructure one.
this one, and not column itself. Do you understand now?
Okay.
We are considering.
Okay.
So let me pick it again. So number of reinforcements, you have it to be 4 number. So 4. Number of column, you have 30 for column 1. The length of the column starter is 3 meters. The bend, we measure it to be 0.18. It seems, and the weight is 16 mm. See, we are done. So let me change to column starter 1. Column 1. So we click OK. So what we are going to do is just to click on this like this. So we have gotten our value for reinforcement. You see here, 602.93 kg. So you can cross-check by doing manual measurement whether it's going to be equal to this. If you cross-check. So that's all for this column starter. We can do the same with other columns. Do we understand this one?
Yeah.
Or I should come again? Do we all understand?
Yeah, I got it.
Okay. So I would like to stop here. You can look at, is there any other item we've not considered? Is there any other item we've not considered? Hello?
Not really.
Okay, and did we get all we've done?
Okay, with the column, it's left with the links. But I think it's the same principle. The links.
Okay.
Or the
it remains link. It remains,
yeah, or the stereo.
Okay. Let us do that link. Let's do that link before we close. For the link, it's quite different from that, but not too far from it, actually. So if you want to do for the link, you click on template. create another counting tool, count tool, I mean, and write link, sorry, link to column starter, and click OK. So double click on this and click on this. So what we'll be needing for our link, we'll be needing the length of the column starter. We'll be needing the diameter as we did earlier. So let me input all the parameter, the length, okay, do you know what? Don't let me create an, I'll just copy that. Instead of stressing myself to create, let me delete. I'll just copy the one I created to and rename it. So I will copy this, copy and paste. So I will just name this one to link.
Okay.
And change the parameters. So now we need number of column. We need length. We need quantities of iron. But in this, and we need center to center. So let me include center to center of link. C by C, center to center. So let me predefine the center to center. 0.15, 0.20, 0.25, 0.30. That's center to center. So we need the size of our column. We need size of our column. We know the size of our column is 230 by 230. So we know that side we name it side A. One side to be side A. Another side to be side B. So number of side A, number of side B, and we need cover. We have to less cover. There's cover. So cover the number of cover, the number of sides of the cover. So we are going to consider hook, which is bend. Since bend is already there. So out of these parameters now, under the length, to know the total number of our link, we go under length. So number of link, click OK. So to know the total number of our link, so we need length, the total length of our column divided by the center to center, right, by center to center. So you know the number of our link with that. So having known the number of our link, the total quantity, so quantity of iron is going to change. So sum of side A, okay. Sum of side A, sum of side B. So to know the sum of our side B, total number for our side B, we drag it in front of sum of side B, multiply by side B, and know that our side B is going to be deducted from cover. Our cover. So side B. So side B. So net of, let me name it net of side B. So net of side B is going to be side B minus total number of our cover. So another one, total number of cover, total cover. So our total cover is going to be number of our cover, multiplied by cover. So it's going to be the total cover. So our net B is going to be side B minus total cover. So we've gotten our value for net of side B, remaining that of side A. So net of side A, net of side A. So net of side A is going to be side A minus total cover, because we are going to less total cover from it. So having done all this, so this one sum of side B is going to be number of side B multiplied by net of side B. So for side A, number of side A multiplied by net of side A. So what of hook?
Yeah.
Our bend, which is going to be bent. We can name our hook to be bent. Where is it? These are bent. Let me name it hook. So hook. So hook is going to be considered too. So under our total quantity, after our center to center, number of covers, number of side B, the total quantity of iron. So total quantity of iron we got for sum of side B plus that of side A plus hook. So all this one is going to form our quantity for iron for one link. So now under quantity, we are going to multiply it by the quantity of iron multiplied by the density. Since we are done with all our parameters, so this one we are going to show the number of cover, which is number, unit to number for cover in meter, number of side B in number of side A in number, side B in meters, side A meters, center to center in meter, and length and this one. So all those items we are going to show, we are going to check. This one is among it. We are going to check this, we are not going to check this weights. We have checked weights. Hook, check hook. This one is not applicable here, so we are not going to check it. Number of reinforcement is not applicable. So all these ones we are going to check. All the marked one we are going to check. So all the checked one, I want to move them to the close to this quantity. So if I want to move this number of cover, I will click on this up arrow. So I want to move them up. So number of side A, move them up. Number of side B, move them up. Side A, move it up. Side B, move it up. Cover, move it up. Center to center, move it up. Length, move it up. I want it to be the first one. The hook, move it up. I've been needing all this. The hook, after the hook, seems that's all. Seems that's all, I mean. Let me check again. I don't need this one here. So all these ones, they have been checked and I'll be needing them. So let me predefine this hook. Let's say hook is 0.10, 0.15, 0.20. Click OK. So having moved them up, I'll click on this layout. Hope you are getting it. Are we all following?
Yeah.
Okay. So since we have considered all these ones, number of link. Okay, remains one thing to add. The number of link is going to be multiplied by this number of link. So we are going to multiply the number of link under this quantity of iron. Multiply the number of link, which is this one, number of link, So this number of link. What else again? Hope we are not missing anything out. Sum of side B plus sum of side A plus hook multiplied by the number of link. Since we are on the right track, click form layout. So I would like to show the units of all these our parameters. The units. So I want this number of side A to be in front of this. I click this, click this, click this. Since they are all okay like this, I will click OK. Click OK. So let us go and use it. So link. So it brings this. Our name. Link is Y10. Y10. So number of cover is 2 sides. 2. Number of side A, we have 2 sides. Number of side B, we have 2 sides. Side A, we know that the side of our column is 230 by 230. So side A is 0.23. Side B2 is 0.23. So our cover, what do we want to use for our cover? Okay, I didn't predefine this cover. Let's use maybe our cover to let 0.025. So center to center. It's just center to center. It should be there. The same is 150. Let us use 200. You check later. The length of our column is 3.0. The hook, let's say the hook is 0.15. The density is, okay, I didn't predefine this density, 0.616 is Y10. So width is 10. So we click, we missed one thing, the number of column. You have to consider that number of column. So let me cancel it. Number of column. Let us go back to template. Double click. So number of column. Number of column is going to be considered. So we are going to multiply this all our quantities by number of column. Number of column. And we are going to check this column too. So we move it up, take it up. So they are in order. Okay, you can use it now. So let us go back to home. Click on this link, Y10, number of cover 2, number of side A2, number of column is 30, number of side B2, side A 0.23, side B 0.23, cover. Let's say cover is 0.025, center to center. Let's assume is 200 mm spacing. The length of our columns 3 meters. The hook, let's pick 150 mm. The density is 0.616, and the weight is 10 mm. So we have computed everything. We click OK, and we just click on it like this. So the quantity for our Y10 has been generated, which is 231.57 kg. So let us check it on under estimating. So this is the total quantity for our Y10. So you can cross-check whether what we did is correct, but it's going to correct. It's going to be correct. So these are quantities for Y10. So I think we all understand all we've been teaching so far. So I want any question on all what we've done. Wherever we are not clear, we can ask question before we close for today. Any question? Any question?
Can I see the calculation you did on the ground beam? I think I wasn't online.
Okay, ground beam. Okay. So templates. So under ground beam, don't worry. Yeah, I'm going to share all the videos with everyone after the training.
Okay.
You are going to see everything. So
Okay.
that's why you are not clear. You are free to chat me up. I will clarify everything. So
Sure.
Is there any other question? Any other question? Any other question? No question, Abi. So I would like to stop.
Please, I have a question, please.
Okay.
I realize as we are doing this thing, there are some things you were checking, like you check some boxes. Please, what are the implications if one forgets to check?
And this is
all
why
these
I'm
boxes?
checking all those columns. Is that all those ones that I'm checking? They are variable columns. Variable columns are the ones they are liable to change, and I have to check them for me to input my parameters. Like this one now, under length, I check length. What's the length? I didn't put anything. So I have to check for it to show whenever I want to measure. All these ones that I check, they are going to show. If they show, I will just input all the required the dimensions in front of them. If I didn't check them, that means it's not going to show. Like this now, let me uncheck length. For example, let me uncheck length. I've unchecked length. I click OK. So I want to measure. I click link. You see now, on all these ones now, there's nothing like length there because I uncheck them. There's no length there. So if I continue to input these parameters for all this number of cover, number of side A, without without consider the length, that means I've done wrong. Are you getting it? Do you get it? Hello?
Yes, yes.
You get it? So I unchecked length. So length is not showing. That means there's no dimension for length. And doing that is going to be an error. So I have to go back under my templates, double click on this link, What's wrong? Sorry, templates. So double click on this advanced and check and click check. So once you check, it's going to bring out the length for you to input. Maybe the length of the iron is 2 meters, 3 meters, any dimension, you just input it. Do you understand now? Are we cleared? Hello?
Yes, yes.
So I believe there's no other any other question. So I will conclude for today. So in absence of question, I would like to stop here. So we'll be meeting next week by God's grace. Thank you for joining. I wish you, everyone of you, best of luck. Thank you.
Okay, thank you too.